So, good morning. My name is Jose Manguez. I'm co-PI of the 6G Blur project together with Sandra Lajen, and we're here with Carlos Navarro, who is one of the team members of the Keysight in the 6G Blur project. The 6G Blur project is a UNICO R&D project funded by the NexGenerationEU funds, by the Spanish ministry through the Resilience funds. And it's about the disaggregated run and how we configure this disaggregated run and how we put it in an end-to-end view. And we do joint optimization, not just of the run, but also end-to-end. And we're here basically to discuss a bit with Carlos and Michael what has been the contribution of Keysight to the project, and we're really excited to be here discussing with Carlos.
Thank you, Josep. We are indeed really excited to be here at the Keysight booth showing the latest results that we got in the project. In particular, our role in the project was to study the use case of centralizing OpenDUs into a point where we aggregate most of them so that they don't have to be deployed disaggregated. This, which has very many advantages in terms of ease of deployment, however, has the challenge that we need to have an extra long front haul. In order to assess the challenges that this implies, we have mounted a testbed in our labs in Malaga. The testbed consists of the following elements. We have our radio unit emulator, RUSIM, which emulates traffic over the ORAN front haul. In addition, we have at the other side a DU powered by SRS software, which is going to take care of the processing of the input that comes over the front haul. In order to emulate these very long front hauls, we make use of our Network Emulator 3 equipment. This equipment is able to emulate large delays, those that would correspond to a fiber connection with a really long length. In addition to that, we plug at the other end our core emulator, CoreSIM, which takes care of having a full stack implementation in the test.
Thank you, Carlos. Can you provide more details about the number of radio units and the number of users that you can simulate in the RUSIM, and also the environments that you can emulate with the Network Emulator 3?
Well, in terms of radio configurations that we can emulate with RUSIM, we can emulate in the default hardware in which is sold up to 2 radio units with 2x2 MIMO configuration, or we can emulate a single radio unit with 4x4 MIMO configuration. Regarding Network Emulator 3, in addition to emulating delays, it can as well emulate packet drops, or it can emulate packet reordering effects, among other impairments that it can add.
And can you summarize the main outputs of the studies that you performed?
Well, one interesting finding that we got is that the performance of the DU is more or less unaffected up to a propagation delay of about 1 millisecond. That would correspond roughly to 200 kilometers fiber length.
Okay, thank you for the explanations, Carlos. Really interesting. I have no doubt that this will be of interest for Telefonica and many other operators on how to dimension the network. Just one final question. What did it mean for Keysight to participate in the 6G Blur project?
Well, participation for us in 6G Blur and this kind of projects is very important, right? We need to be able to upgrade our portfolio with the latest use cases and the cutting-edge technology. For us to cooperate with research centers such as CTTC gives us an incredible insight into what are the new trends that are coming, and therefore what will be the needs that our customers will have in the near and long-term future. So for us, it's really important to be into this research environment and to be working in cooperation with both the academic and the industrial research partners that we have.
Okay, thanks a lot, Carlos. It's indeed a pleasure to work with you.
Likewise.